So we start with Git and GitHub. Firstly, what is Git? So let's say you're working on a particular project on a website, you're making some changes every day in your reports, in your project folder. So you have a simple project folder. You can call it like website 1 or website 2. Let's say you have a project folder called website. And you're adding your changes onto that every single day. You're making those changes locally. You make some changes today, it works perfectly fine, you're very happy. You come in tomorrow, you want to make some more changes and you're happy with the changes and it works perfectly fine. You come in the third day and you break your changes. You don't like the look and feel of it. And you're thinking, I wish I could just go back to how my code looked yesterday. So how do you do that? I mean, think of it like when you were in the university, or I was at the university, what I used to do with my Word documents is, okay, report 1, next day report 2, report final 2. So I was manually versioning my files because that's what Word documents are. Word document doesn't allow you to time travel back. If I'm editing a Word document, there is no way I can time travel back and say, okay, last month, I want to switch to how my Word document looked last month. So that's not possible. That's what Git allows us to do, okay? So Git and GitHub, they are both, and I'll tell you. So basically Git is something called a VCS, which is a version, just bear with my handwriting. VCS, which is called a version control system. It's a software that allows you to manage and track your changes, okay? It is installed locally on your system and you don't need any internet to do anything with Git or run any Git commands, okay? And you don't need any account to run anything related to Git. So this is a software, and it's not the only version control system software. There are some others as well, like Subversion, Mercurial, but by far, Git is the most popular version control system, okay? Now we have GitHub. What is GitHub? GitHub is actually a service that is hosted on the cloud where you can take your, so let's say you have this project folder, you're very happy with your website. Now you want to share this folder, which is on your local computer with your friends. Okay, how can you do that? How can you give them a copy so that they can look at those changes and collaborate as well, or make some recommendations or add some changes to it? That's where GitHub comes in. GitHub allows you to share your Git project folders with your friends or with other people or the open source community, not just friends, with any developer in the world. That's what GitHub will allow you to do. So you have a local project folder that you're working on and you upload it on the cloud where GitHub will store your project folder. So it's a service, okay? It's running on some cloud. It does need internet access. So if you want to work or collaborate on GitHub, you do need internet access. And you also need to create an account, okay? And GitHub is, again, not the only collaboration tool where you can host your Git repositories. There are other tools as well, like GitLab and Bitbucket. But this is by far, obviously, the most popular tool, and hence we are going through Git and GitHub, okay? So that's an overview of what is Git and GitHub. Next, we look at how, so I said, okay, Git is a version control system. It will allow you to track your files and folders. So how does that happen? So think of a project folder that you have. This is, let's say, a project folder, if we call it, let's say, demo, on your computer. Now, how will Git know that it needs to track that? So you need to run a command called git init. When you run this command, and I'll show you as well, but I'm trying to explain the concept first. Let's try to understand things from a concept side, and then we'll look at the commands as well. So when you run this git init, that's when you need to be in this folder. So you are in this folder, we say cd demo, that means change directory. So you are in this folder, you're pointing to this folder, and you run this command called git init. That's when Git knows that, okay, I need to be monitoring this particular folder or tracking all changes. Now that means it will track not just this particular folder, but all files and directories within this folder. So it's recursive, okay? Everything within this will be tracked by Git. How is Git doing that internally? So when you run this git init command, and I will again show you when I do it, actually you will see another folder within this, which is called .git. And when you try to look at what .git is actually meaning, this is a hidden folder, okay? And when you go into this folder and try to inspect the files over here, you will see a lot of things internally that Git is doing to manage. So you'll see something called head, you will see something called refs, and I'll walk you through what actually some of this means, because it's useful to understand, to again get an understanding of what those commands are actually doing. So if we try and go inside this folder called .git, you will see these internal directories that it is using to track all your files and changes, okay? Now, in case I have run this command called git init, okay, git init will create this folder called .git. And in case if accidentally I delete this, okay, I delete this folder, all your changes are lost. Okay, so even though you have initialized it and you've told Git that, yes, I want you to track these changes, if accidentally this folder is deleted, your repository is no longer being tracked and you will lose all the history that you had so far. That is why this is hidden, so that even by accident, someone doesn't go and delete it. There's a reason, okay? So it's hidden and you go into it only if you know what you're actually doing in it. So we don't want to accidentally delete this file. That is what Git initialization is doing. Now, when it comes to Git, there are certain areas that we need to understand. So let's look at that. So, okay, let me go through the commits first, okay? So how is Git tracking all of these changes over a period of time? Okay, so let's say I come in, I make some changes today, okay? I come in tomorrow, I make another bunch of changes and another bunch of changes. Now, these changes are actually, you can think of it as a snapshot or a checkpoint in time, okay? So these are some checkpoints every day that I'm making. So this can be 1, this can be 2, and this can be 3. These checkpoints are called commits, okay? So Git will only be able to track when you tell it, this is my checkpoint. So that's why it's recommended that you should commit as frequently as possible rather than making changes for months and then making one single commit. So you need to tell Git, make Git aware that this is the checkpoint I want you to track. And that checkpoint is by making commits to your Git repository. Repository is a term that I'm using, but basically it's any folder that is managed or tracked by Git. That's your repository, okay? So those are the commits that are happening in your repository, and that's how Git is tracking. So you have to tell it what are the checkpoints in your particular project that you wanted to track. Now, take this. Okay, let's try to understand how this is working. When you're making a commit, what happens in the background? So we look at it in a different perspective. So you have your local folder, we call it your working directory. Okay. And then you have Git requires something called as the staging area. And again, I will show all of this in the command as well. So don't worry about that, but let's try to understand the concept. And then you have something called the local repository. And then you have something called the remote repository. Okay. So remote repository is where GitHub comes into play and where you need internet access. So this is something that we do later, but this is the GitHub area, your remote repository. Okay, let's come to the local. So you have your working directory, which is your own project folder. Then the staging area is something that is internal to Git. You don't create any staging area, but this is what Git expects you to tell them. So let's say you are making some changes to your file. Okay, you added one file, you made some changes to it. Now Git wants you to tell Git or notify Git that these changes are ready to be committed. So that's where you need to use a command called git add. So when you do git add, it is actually putting these changes that you had in your working directory into this staging area. When it's in the staging area, it tells Git that my changes are ready to be committed. Okay, because in your working directory, you can have a lot of things going on. You can have log files, you can have some random zip files, and these things happen when you will work on big projects. You will have a lot of files which you don't want it to go into the Git repository or to be committed. So that's why Git consciously asks you to add anything that you want to be committed into the staging area. So that's the staging area for Git. Now to make that commit and for Git to track that's what I said, that you need to notify Git of these checkpoints in time, that it can time travel back. When you want to actually commit these changes and make Git aware of them, we then have a different command, which is called git commit. So when you commit these changes, you will see Git is now tracking that change. It will keep track of that change. And that's where if you want to come back, if you want to undo those changes, you can come back to it. So that's basically the workflow from your working directory to Git tracking that in your local repository. You need to do a git add to put it in the staging area first. And there are commands, right? You can undo your changes from the staging area. We'll cover those today. You can undo your changes from the staging area. You can undo your changes from the Git local repository as well. Okay, so yeah, that's about what it is. And I think, looking at my notes, is there anything else that we need to cover here? Yeah, okay. So let's just go into the system now and we'll try and walk through these things. Okay, you're able to see my, yeah, okay. So first thing first, yeah. Is this font size okay? Or do you want me to increase it? Okay, yeah, this should be. So we check first, we have git installed, the command is git version, and we make sure it is configured correctly. Another important thing to set up your Git is to make sure you have added your name and email address. And this should be the same as your GitHub account. Because otherwise, GitHub, that's the way GitHub kind of recognizes you. Otherwise, you can be making some changes into your GitHub repository and you will not get enough collaboration credit for that. So how can you do that? How can you check if your configuration is set up correctly? So there's a command for that. You can do git config, and it will show you whatever is, however your username, your email has been configured. So you can see that's my actually GitHub account name. That's the account name that I use in GitHub, and that's the email address that has been configured. So make sure this is set up correctly, and you can do that by running this command called git config. We use the global one so that for all users, but you can omit this as well, it's not required. And then you use these keys. It's called user.name, okay? User.name and add whatever you want. So I'll just put random for now, okay? And if I do a git list now, you see that's picked up random. So I'll just change it back because I do want my correct name. Yeah. And similarly, for the email, you just change this to user.email and add the correct email ID, okay? I'll not change that. So yeah, that's the first thing. The second thing I would recommend is, and you can actually find this information in the documentation as well. So if I go into, so yeah, this is actually the official GitHub documentation. I'll share these links as well. When I send out the exercises, you'll have access to all of this material. So you can go into the official GitHub documentation, and there's this book as well if you want to deep dive and understand things more, it's free to download and you can read all of this information. But under the appendix section, you will see something how you can configure your bash. And I won't go into the details because everyone would be using a different bash. It's different for Windows, Linux, and Mac. So I'm on Mac, and it gives me the instructions to kind of autocomplete my GitHub commands. It's not a showstopper, but obviously there's a better user experience. And it will also show me when I'm running my commands, which branch I am currently on. So it is available in the documentation. It's useful to have that because visually it's a better experience. So you can follow that documentation for whatever bash prompt you're using, whether it's PowerShell, it's bash, or on Mac. So what that means by autocomplete, sometimes I can be, if I just type git config and I click on tab, it autocompletes the command and I don't have to always remember it, right? So I can do hyphen and I'll do li and I click on tab, it autocompletes the rest. So it's just helpful. Otherwise, it could be a bit overwhelming to remember all the commands. So it just helps if you have that autocomplete option completed. You can type a few letters and click on the tab key and it will autocomplete for you. So yeah, if I look at what's there in this folder, I currently have a few folders. I'm just going to remove this one. Okay, so yeah, I just have one folder, which is the Women Who Code London repository. So let's say I want to start a new project and I'll just create a new folder, okay? And we go into this folder. So currently you see there's nothing in this, and let's open this as well. So yeah, we currently see there's nothing in this particular folder. And if I go in just to git init now, so that's the command. So now I want Git to track this particular folder where I will be adding my project files. Okay. So now it does give me this horrible prompt, but don't be scared. I'll explain all of this. So this is saying that by default, we are using the master branch. Now, recently, okay, and it tells you you can configure your default branch, and they also suggest you to rename it. Why is this? Because recently, GitHub actually promoted by default, we've always been using the default branch as master. And to avoid using any kind of offensive language, GitHub, I think it was in 2020 that they started moving to using a better term called main. And a lot of organizations are moving away from using any kind of offensive language. So they don't want to promote the use of the term master. So that's why everyone is now trying to say we should, or Git is now, that's what it's recommending, that instead of master, you can choose the main. So it's by default, the client, and I'll show you when we go into the GitHub thing, by default, the client is creating the default branch as master, but it gives you all the information so that you can change this name from master to main to comply with better naming convention. That's all, okay? Don't be scared if you see this horrible thing. It's all working as expected. Like I said, when you run this command, git init, you will see this .git folder in your file, which means now Git is tracking this particular project or this directory. And if we try to go into this, you will see it has all of these different files and folders to track your changes in the repository. We make some commits and I'll show you what is actually involved in over here to give you a better understanding, but once we make some commits, okay? So yeah, nothing to be scared about this. We will change the branch when we cover branches. There's a very simple command that you can do to rename your particular branch, and we'll do it at a later stage. But let's continue with master for now, okay? So let's just say, I'll just go back to my folder and I'll just create some file. Let's call this demo1.txt, okay? So one command, so I've just added some file. You can see that over here. I've added one file in this repository, and now I want to see what is the status of my Git repository. So there's a command called git status. And again, this is something that you should use very frequently at any point of time to see what's the status of your repository. Okay, So it does say, okay, this is just a Mac internal file. We'll ignore this for now. And I will show you how you can ignore this because again, this is something that you will face on a very regular basis. So that's the file that I created. And Git says, okay, you have these untracked files. Better. And Git is telling me, okay, this file is untracked because this is currently in my working directory, okay? And like I said, you have a staging area in Git where you need to notify it that, okay, I want you to track this file and stage this for to be committed. So the command for that, like we saw, you do git add demo1. You can do all as well. So you can do one file or more files. So if we had more than one file, I could have done like demo2.txt. We don't have it now. So you can add multiple files by a space, or you can do all. So if you have like 2 files and you do a dot, it will add all the files to the staging area. This is an internal file and I don't want Git to track. And I'll show you how you can handle use cases like this as well. So I don't want this to be tracked by Git. That's why Git tells you that you need to add them and tell me that this is ready to be committed, or you want me to track it. So that's why we have this command. I don't want Git to track this file, and I'll show you how we can manage this. So git add, I will just do demo1.txt. Okay, so I've run that command. Let's look at Git status again. So now you see it says changes that are ready to be committed, and that's the file that it's ready to be committed because this is in my staging area now, and this is still in my working directory. I don't want it to be tracked. Okay, so now I am happy with this file and I want to like commit it. So we can run the command. I'm just using the short form, but I'll explain what this is. So -m just means a message, and I will add a message called add demo1 file. Okay, so -n means you're adding a short inline message, and I'll walk you through what's the right way of adding your commit messages. But for now, let's just keep it simple. Git commit -m, and M means this is the message, a short inline message that I want to add. Okay, so it tells you that, okay, you have added this demo file, you changed one file, but obviously there was no files but there were no lines in this file that changed. And then it just created, this is more specific to Mac or Linux, it gives you the mode, but you can ignore this for now. So yeah, basically it's adding a new file called demo1.txt. So now let's look at Git status. Okay, now it says you are on branch master. There's just one untracked file, but nothing added to commit, but one untracked file is present. Okay, so it's saying there is nothing ready, nothing added to be committed, but there's only this one untracked file. Now, what Git allows us, if you have more files like this, okay, you are in your repository, you're running some, let's say, script, which is creating a log file, and you don't want Git to track these files, okay? By default, Git will track all of them and tell you, okay, you need to add this to the staging area. I see one file in the working directory, and it has not been added to the staging. So it will keep reminding you. But actually, I don't want it to track this file at all. I don't want Git to remind me about this file at all. So for that, Git has something called a file called .gitignore. Okay. So that's what it is. And I will add this file into it. Okay, so I don't know, it's big enough or not. Yeah, so I'm just saying that's a file that and this is a standard. The file should be called .gitignore. It just means you're telling Git, ignore certain files and don't remind me about it. I don't want you to track them at all. You can add anything else. So you can say, I don't want you to track any file called .log. That star is a wild character. It just means don't track any file called .log. Okay, and we save this now. And now we run Git status again. So now it is not reminding me about that file anymore because it understands I don't need to track it, but it does tell me, okay, you have a .gitignore file that needs to be added to the staging area and committed. That's when it will, it's kind of in your Git history, because even this file, over a period of time, you can change the files which you wanted to be tracked and not tracked. So let's quickly add this as well. So now I can use this dot. So it will add everything. And if I do git status, I just add one file and I will just do git commit. And then, okay. So we've done that and we run a git status. So it says on branch master, there's nothing to commit. Your working tree is clean. So now I don't have any more changes. Everything is up to date. There's nothing in my working directory and there's nothing in my staging area. Okay, so that's the basic workflow of how things are getting into the commit history of Git. Regarding adding Git commands, I use the short form, but let me actually switch to another repository. That was the W. Okay. Okay. Sorry. Let's look at one. So we look at the Git status. Now let's look at the history of this repository. And I was telling you, Git will track based on the checkpoints that you give it. Okay. So let's do a Git. So how can you see the history of this particular file? You run a Git log. And you can see these are the changes that were added on this particular date, who was the author, and this is the commit message. Okay, so add demo1 file and .git ignore. Now, keep this in mind, and I will cover this in detail on what's happening over here. But you see, every commit has a hash, and this is the unique identifier of your particular commit. Okay, and you see it has something called head points to master. I will explain this in a bit, but I'm just trying to get your attention to what this git log message is saying. There is a commit and it says your head is pointing to master. Okay, I'll explain this. So now I wanted to show you why it's important or what's the best practice for writing a good git commit message. Now, this is a very simple or a demo repository that we're doing. So those one line short phrases is good enough. But when you're working or collaborating with people on big open source projects, you will be making a lot more complex decisions related to some of the changes that you've made on the server side, or you've implemented certain sort of caching within your website, or you've chosen a particular data structure over another data structure, or a particular sorting algorithm over another sorting algorithm. And it's very important to give your collaborators as much information as possible to understand why those changes were made. So if I look at our, just switch to our Women Who Code repository. Okay, so I'm gonna, so it's showing me my different branch, which is called update code owners, but we can ignore that for now. Let's just increase this a bit. So let's look at the git log over here, okay? So you see the git log message consists of multiple lines here, okay? Sometimes it's a simple change, but other times you can see there's quite a lot of information that's given, okay? Add a front-end readme, what was added, where was the feedback, some of the other changes. And this is what you will see usually in an open source project, okay? Sometimes you will see issues being added as well. So there's a lot of information that's added to your git command. Now, using the format that I just showed you, it will not be possible to add all of this information. I just used a short message, which was git commit -m, which is adding a short message to add, but it will not be possible to do that when you want to add all of this information in that one single line, okay? So yeah, like you see, there's a lot of information that is added over here for most of the commits when complex ones are made. So I'll just quit this. So how can you add all of this information, which is the recommended way of adding your Git commits? You can add information about the issue that resolved as well. So let's go back to our to the same repository. Okay. I am just going to look at the chat actually, because I see a lot of information here. So yeah, I haven't been keeping track of this. Okay, the command between staging area and the local repository, it's called git commit, yeah. So the meeting will be recorded. So don't worry if you miss some of these information, you will have access to them as well. How do I change account? How do I Change account. I'm not sure. Oh, you mean the name of your account? So that the command was git config. Sorry, I just got distracted by all the messages. I realized I haven't been tracking them, so I'm just answering a few, and I'll come back to this actually. How do you change the account on the git config? You just have to type git config, and you can use the global flag because it will apply to all users on your account. And then it's called user.email, and then you whatever is the name that you want to add. Like for me, it was Haritwal. And it's the same if you want to change the name. It's called user. Now again, this information is available in your documentation as well. So if you want to look at those exact commands in the book, and you will see called in the appendix, setup and config. Okay, you can go into this and you will see those commands. So this is again to change your editor. This I'm going to touch this in a bit, but yeah, this actually has the information. Go into first time git setup on the files that, so you see git config global username, git config user email. Okay. The screen Mac, the standard Mac command line, or is it within the Git app? No, this is the standard command line. This is just the terminal that I'm using. Okay, so depending on the operating system that you're using, it can look a bit different. So you can have Bash, you can use PowerShell. But yeah, this is basically a terminal. It's standard, it's nothing specific to Git. On Windows, when you install it, you will see something called Git Bash as well. Okay, so you can use that Git Bash terminal to run these particular commands. We it was a prerequisite. I wouldn't be going into how you use a terminal because that will just consume a lot of time. But yeah, we're not doing a lot with the terminal. We just need to know how you can make a directory, how you can navigate the folder system or change directories, like a cd command that I was running. And I did mkdi, which means make directory. So that's all that we will be doing on the terminal. There's nothing more. It's not too advanced with the terminal. No, so this is the terminal in Mac, but you can use any terminal that you want. Like I said, Git app and Git bash. Yeah, it's terminal. Oh, how did I open the .git ignore file? Yeah, I will monitor this now. Sorry, I haven't been monitoring. So, yeah, because it's a hidden file. So I have configured my system to show the hidden files, but on your system, if you just do ls minus la, a means show me all hidden files as well, you will see it. Okay, so anything that's dot is actually hidden. So you will see this file if you run that particular command on your system. But even on Windows, there is an option at the top where you can see to show you all the hidden files. Okay. Did she open a new text file and saved it as well before committing? Yes, I did. I did open. I created a Git file. I made the changes and I saved it. Thank you, Sumaya, for answering all of these questions. Yeah, I just had an empty file and I just changed it. Yeah. Yeah, you can open it in Notepad as well. That's absolutely right. Because I'm on a Mac, I'm using the terminal. So you want me to increase? Okay, I will increase the browser front size. Yeah, you can use anything. Like it will be sometimes Python files, or for Gitting, no. No, I'm just trying to create some demo files, but in the real world, these can be CSS files or Java files or your Python script files, Bash files. But for the purpose of the demo, I'm just using .text files. But obviously, when you're adding a README, that will be in the Markdown. But this is only for the purpose of a demo that we're using just text files because it's easier for me to edit them. That's all. But you will be adding a lot more different files over there. Okay, great. Thank you. I will monitor this now. I was actually missing it and I saw it pop up on my screen that there are some 20 messages. Okay, let's go back, and you wanted me to increase the size of the browser. So this should work. That's too much. Okay, this should be better. Yeah, so I just wanted to show you how you can make those Git messages much more meaningful and add a lot of information. So the command for that is, oh, I don't have anything right now. Git status. So there's basically nothing in this to commit. Let's add another file. So I'm just using a command called touch. This is a command that will help you to create a new file. It's different on Windows. You can go in and create a file as well from the UI. That's absolutely fine. I'm just using the terminal to create this file. Okay. So I will just use, let's say, demo2.txt file. Okay, let's run the git status command again. And we will be running this command a lot of times. So if you miss it once, don't worry. Like I will be running this multiple times like you see. So you see git status, it has another file, and I will run the git add command. I'll just use the dot. Okay. Now, to add a lot of information, the right way of doing this, and this is what you should be doing when you're committing to your to bigger projects, is just type git command, git commit without the -m flag. Okay. So let's do git commit. So when you run this, Git will open your default editor. For me, this is configured as Vim, which is the visual editor. I am comfortable using it. So I will, that's why it's configured like that. But on Windows, you will see this message will open on Notepad. Okay. You can change it. If you're using a particular IDE like Visual Studio Code or Sublime Text, you can configure it and say, okay, please change my default editor from Notepad or from Vim to my IDE like Visual Studio Code. So for now, once I type this git commit, it just shows me my Vim editor. So again, don't go try to, I mean, don't be overwhelmed by this Vim editor. I will just make this change over here, but on your Windows, you will see Notepad++ or Notepad, or you can even configure it for your IDE. So I'm just adding like add demo2, and then you can add more, I don't know, WWC London workshop. Creating new file. Okay. And you can add whatever information you want. So once I've added this, and I will have to save those changes. So that's what it's done. So let's look at our Git log now. So you see, it's picked up that big message over here. Okay. Yeah. So that's another editor. Don't be overwhelmed by the tooling. We're just looking and trying to understand the concept. Okay. The tooling will vary depending on what operating system you are on and which tool you are comfortable with. So if you want to change this, again, this is there in the GitHub documentation. It's under books. When you come under books, you will see the appendix section over here. And it says setup and config. So when you click on setup and config, and if you want to change your editor, just like we were changing our name and email ID, you can set git config global core.editor, and every editor has a different option that you need to add. So if you want to use the Atom IDE, you can add Atom. The wait option just means that wait till I make those changes and I do a control S on that. Once you do that, it will allow you to save those changes. So there are a lot of editors like Notepad, Notepad++, a lot of them. So there's Vim, WordPad. I mean, there are a lot of options. So again, because this is very user specific, you can take a look at it later and configure it or use your default options. Okay. Okay. Is this any better? Okay. I hope this is better. Okay. Okay, great. So yeah, that's how you can configure it. So let's not focus too much on the tooling. It's something that is very user specific and you can change it based on your preference. So now we see we have that big commit message over here, and that's how you should be adding. One thing about commit messages, you see I am using the present tense, okay? So it's important to use, again, it's not important, but like you can add anything. I could have added, my commit message could have been added demo 2, but the industry specific is the recommendation is to use the present tense and say, okay, remove file or add certain file, update certain file rather than update it in the past tense. There's a very good documentation which is available in our contribution guide. You can take a look at that and I will share that again. All of these resources and links will be available for your reference. So yeah, you can read that, but it's very useful in understanding how to write a good commit message. The other thing is we should try and make these changes as atomic as possible. Okay, if you're working on feature 1, all files related to only feature 1 should be committed at a single time, rather than trying to add a lot of files, 10 different files which are related to 10 different changes, because it will be very difficult for you to undo these changes. Okay, so let's say I've made, let me add some random files, okay? Okay, so assume these are all changes that I am making in my repository, and I'm just naming it like this. Okay, now these are certain changes that I made in my repository and I have them in my working directory. Okay. What you shouldn't be doing is making all of these changes, which are related to different features, in one single commit. Because tomorrow, if your feature 1 is working very well, let's say feature 1 and feature 2 are working very well, but you realize your feature 3 is not working and you want to revert that change or you want to undo that particular change. It will be very difficult for you to, or it will be actually impossible. You will have to undo all of these 3 changes. Okay. And we don't want to do that. We want to be able to manage them and track them better. And that's why we give them, I think of it as checkpoints or, think of it as checkpoints. Okay. So my feature 1 is working correctly. I have added that. So your commit message can be add feature 1 working copy, or then when your feature 2 is working correctly, you add feature. So that's like your checkpoint in time. This is where my feature 1 is working. This is where my feature 2 is working. And this is where my feature 3 is working. If you add all 3 of these together and only one feature is broken, you will have to undo all the 3, which is what we don't want. Okay, we want to be able to manage these changes better. And that's why your commit messages should be as atomic as possible. By atomic, I mean like single units of changes. Single unit, like all files related to one particular feature should be in one commit message is what I mean. Yeah, that's all. So yeah, you just use add rather than added. So I could have, my commit message could have been added demo. So instead of past tense, you just use the present tense. Okay. So let's add some of these commits so that we can play with them later. So I will add them quickly and commit them as well. And I'm going to use the short form to save the time, but you should, you know by now that you should be using or writing these messages better. Okay. Let's do the second one. So there's nothing to follow. I'm just creating my history, or I'm just quickly making these changes, running the git add command, and then creating the commit. Okay. So I will do the git status, nothing, my branch is clean. I will do a git log. And you can see we have all of these changes here, feature 1, feature 2, feature 3. Okay. There's another short form. So you can do git log -- one line. If you don't want to see all of those commit histories, we can do this. Okay. So I have a good commit history now. Add feature 3, add feature 2. Okay. Now let's say a useful command to know is, let's say you added a message that you're not happy with, okay? And this is only relevant to the current message. You cannot do this for a commit that you made like for last fourth commit or something. So let's say you just made this commit and you realize actually this is not feature 3. Maybe this is another feature, okay? Like this is another version of feature 2, like this is it, feature 2B or something like that. Or you added a commit message that you think you can improve later on. What you can do only for the latest commit, okay? This command is relevant only to your latest commit, and we do that. There's a typo or there's a spelling mistake. Let's assume there's a typo over here, and I want to change this particular commit message. You can use the command git commit -- amend, okay? And you see it again, this will open in your preferred text editor. Let's not like be too focused on the tooling, whatever text editor you have configured, but this will allow to change this commit message, okay? So I added feature 3, but now I also want to add some more information over here, okay? Like what was my reason for adding this change? So let's say some reason, okay? I've made that correction and I've saved that file. So now if I look at, so initially my commit message was just add feature 3, but now if I look at the Git log, you will see it's picked up that same message called some reason. Okay, so you can change your commit messages. It is only changing your commit messages, okay? If you make any error or if you have any issues with it. Let's skip this. Okay. Yeah, so that was about Git commits, about the basic workflow of making some of these changes into the Git repository. Now, I will walk you through the branches concept. I think that's where we need to go. I covered Git status, Git log, Git one line. We covered the amending also, how you can amend your Git commit messages. We walked through that. Yeah. Let's go into branches and we'll walk through branches and commits and the head of all of that. Okay. I will switch my screen again and go into tabbing it. Okay. Cool. So that's where we were. We did the whiteboard session. We did the working area and the repository. Now we will look at branches. Okay. So what is the Git branch? What is ahead? How these commits are changing? Let's say you have this particular folder. Okay. This is your current working directory, and we call it master, main. Whatever it is, we'll rename this in a bit in this section as well. Okay. And then you have this working copy in production or in general. This is where your production ready code will be. This is considered to be sacred. At any given point in time, whatever is in your default branch, that can be called main or master, should be a working copy of your code. This is all working. You're very happy with it. Now, let's say this is a website that you're working on, and let's say you want to work on certain feature. You want to experiment with the dark mode on how this website will look with the dark mode, or you want to change some navigation panel within this navigation bar within this website. So it could be any feature. So let's say you want to work on feature 1, and then you want to work on feature 2, or another feature. Okay. So how can you work on this particular project without impacting its current state? You don't want to break what is there, but you want to experiment on certain thing which you don't know you will use or not. You just want to go and have a play. If it looks nice, if it works well, you want to promote it to your final website, which is working. That's what branches allow us to do. You can take a copy of whatever is in master and create a new branch from it. You can call it anything. Okay. Now these and this is independent of each other once you branch. So you can break anything over here, do whatever you like, but your master will be working. Okay. Your master will continue working. They are independent. It's the same thing. Your feature 2 will work so maybe in your feature 2 branch, you want, so let's say in the feature 1 branch, you want to work on dark mode. Okay. It has all the changes which are there in master, and now you want to work on dark mode. In feature 2, let's say you want to work on some navigation bar. Okay. Feature 2 has all the changes in master and your navigation bar. Okay. Feature 2 does not have this dark mode experimental changes because it's still in experiment stage and you can experiment with different things in parallel. That's what branches allow you to do. You can work on your navigation bar. Let's say when your dark mode is ready, you can merge, and that's where merging comes in. You can merge those changes back into master. Okay, but we'll look at merging later. Currently, a branch just allows you to work on a copy of your default branch without breaking anything in the default branch. Okay, so these, again, I will go back to the terminal and show you. So these work independently so that you do not break anything over here. Okay, does not impact each other as well. So that's the concept of branches. Now, I will, okay, let's try to focus here a bit because I'm going to go into head. What's the head? What these commit messages mean actually. Okay. Yeah. So what is a commit message? So we saw the commit messages and let me rotate this. Okay. So let's say you have, this is your first commit. It has some hash, which we saw in the Git log. Okay. It has some hash, ABC, and some other thing. This is your second commit message. Okay. XYZ. And again, this is your third commit message. Okay. I don't know, DEF or whatever that is. Okay. This is your first commit, second commit. So let's call it C1, C2, C3. These are the different commit messages. Each of these commit messages internally, what's happening, okay? All of them have a parent and a message. So the message is what we are adding. What is the parent? Now for the first commit, this is none. Okay, and again, it's quite interesting how it works in the background in terms of data structures, but I wouldn't go into all of that, but this is basically what is happening internally. So every commit has these two attributes. It has a parent commit and it has a message. So now, so this is the second commit, and this has a parent. So for this second commit, the parent is C1. So actually this hash is pointing to the previous hash. That's how the sequence is, and they understand this is your commit 1, this is your commit 2. And then we are obviously adding another message. Then this is the third commit, which will have a parent, and this is pointing to this particular hash in C2. Okay, that's how your commits are. And then you add a third one, and the third one will know, okay, my parent commit is the C3. How does it? So these commits, C3 is basic. I'm just naming it anything, but basically your hash ID is the identifier for your commit. So that's how your next commit will know who your parent commit is based on these identifiers. Okay. Now, when we create branches, what's happening? So imagine this is your master, right? This is my master branch where I made all of these commit changes, C1, C2, C3. And when you, and what is happening at master? So you have a pointer here. So this is the last commit in my master, assume C3 is the last commit. Your master, think of it as like a pointer or an alias. Your master always points. Now this is just like I said, a pointer or an alias will always point to the last commit in your branch. So when I say master, it means it is pointing to the last commit in your particular branch. Okay. So if I add a new, so this is basically a pointer. If I add another new commit in my master, right? So I add a commit called C4. Okay. This will again have a parent, which is pointing to this one. Ignore my diagram, which is pointing to C3, and it will have a message. What happens to master now? So your master in that particular case will switch from C3 to C4. Okay, and that's what happens when you continue adding more commits. At any given point of time, your master or whatever your branch, so let's say I create a new branch called feature 1 or feature 2, it will point, it is basically a pointer to the last commit in that particular branch. Okay, so now when we branch, what's happening? When I want to create a new branch, what happens at that point of time? So the git command is very simple, and I will show you the newer command. Like you can use the command called git branch and name it, but there's a newer command called git switch, and that's what we will be using. So when what happens when I'm running that command in the background. So again, so take this. Okay. Yeah. So again, let's go back. I have this is my master branch, and we have some changes, C1, C2, C3. Okay, this is where my master is pointing. And I told you master is just a pointer, which is pointing to the last commit. Okay, now I create a new branch over here. Okay, I'm going to create a new branch over here and say, okay, I want to create a new branch from this particular place, and we call it, let's say, feature 1. So internally, feature 1 is pointing to the same commit, this C3, as master. Okay, so both your feature 1 and master are pointing to the same commit at this point of time. Now in my feature 1 branch, I make some changes. I'm experimenting. Okay, so I will create some more commits here. Let's call it A1, A2. Let's make the first commit. I'm calling it A1. What do you think will happen at this point of time when I make this A1 commit? My feature 1 pointer will move from C3 to here, to this A1 commit. And we will see all of this in the Git log, but try to understand what's happening, okay? So when I created a branch, my feature 1 was pointing to C3. I made some new commits. I added a new commit. Let's call it A1. At this point of time, my feature 1 is pointing to this new commit. I add another commit, A2, okay? So what will happen? My feature 1 will now point to A2. So this is just a pointer which is pointing to the last commit in that particular branch. That's what I'm trying to explain. Okay. And similarly, as and when you add more commits, this pointer will move to the last commit of that particular branch. That's what actually means when you say, okay, feature 1 branch. Your feature 1 branch is actually a pointer to the last commit in that particular branch. Okay. And you will see these messages. Your branch is 2 commits ahead of master or 3 commits behind master. That's what it means. So over here in this particular case, your feature 1 is 2 commits ahead of master. You will see these messages when you're trying to do a git status. It's very common. Similarly, if someone comes in and now makes new changes, okay? Let's say it's a collaborative workflow. I know we haven't considered that, but let's assume now someone comes in and they come in and make, I'll change the color. They come in and make a new change like C4. What will happen at that point of time? Your master will move from C3 to C4. At this particular time, you will see a message. Your feature 1 branch is 1 commit behind master because it doesn't have the changes that are there in master. Okay, so that's what I'm trying to explain, that what happens when you see those particular messages. So this is what is happening when we branch out, and that's how it relates to the commits. Okay, so my branch was created. It's important. My branch was created with the changes in C3. So feature 1 again. Okay, let's try it. Feature 1 has all of these changes. This is the commit history in my feature 1 branch. I have A2, A2's parent is A1, A1's parent is C3, C2 and C1. These are the commits that is there in my branch. Okay, it doesn't have the C4 commit. Now at this point of time, At this point of time, I want to say, okay, I want to create a new branch from C4. So you can create a new branch from here. And let's just say I decide I will create a new branch from here and I call it feature 2. Okay. So feature 2 is pointing to C4, which is the same at master because there are no new commits. So it is exactly the same, right? Now, if I add more changes to it, I add, let's say B1, B2. At this point of time, my feature 1 will change from, will change from C4 to B2. It will point to B2. And at this point of time, what are the changes in my feature 2 branch? So now my feature 2 branch has all of these changes. Okay. So B2, B1, B1's parent is C4, C3, C2, C1. It doesn't have any of the changes in the feature 1 branch. That's why it's important to understand how your commit is linked to the parent commit. Okay. That's where the chain kind of goes down. So this is what branching is happening. What is head now? So if you understand all of this, try to explain what is head now. Head is the entry point. When you are in your working directory, head always point out to the checked out branch. So when you're in your working directory, and I was in master all this while, and it was constantly showing me you're in master, that's where my head is pointing. So if I, at that point of time, when I make any changes, head means whatever changes I'm making will go into the head. And where is my head pointing? It depends on which branch is checked out. Okay. So if I have a command, so the way you can change branches, so you are on master branch, we have been on master, right? We want to switch to feature 1. So in that particular case, I will run the command. Git switch. So currently our head points, so we've seen that in the Git log, right? Head points to master. So my head, I'm just going to put it here. This is where my head is pointing to, okay? And I say, okay, I want to switch. And I run this command called git switch feature 1. Git switch feature 1. What happens at this particular point of time? I have checked out, when I do git switch feature 1, Git will export all the commits that are there in this feature 1 branch. By that, I mean all of these changes. Okay, we'll see this when I run the command. Okay, you will have all of these particular changes. And when I switch to, okay, let's say we are in this feature. So what happens when I am in git switch feature 1? I have all of these changes in my repository and my head will now point to feature 1. That's what's happening. That's what it means, that now your head is pointing to feature 1. So any changes you make in your working directory will go in your feature 1 branch. And what is feature 1? Actually, feature 1 is pointing to this commit. There's a different thing. Feature 1, your head is pointing to feature 1, and feature 1 is nothing but the latest commit on your branch. Okay, so that is where your head is. If now I run the command called git switch into feature 2. What would happen at this point of time? I will lose all of these changes in my working directory. I may not lose it. Git still tracks it. So you will not see these changes anymore in your working directory. You will see these changes in the feature 2 branch. Okay. And your head will move from here. Basically your head will move from here to here. Your head points to feature 2 pointer, which is basically nothing but pointing to a particular commit, which is this particular B2. Okay. So that is what is happening when you're switching between branches, and you will see it in the git log command, and I'll show you as well, so it will make more sense on what is happening in the background. Okay. yeah, I think I covered everything that I wanted to relate it to. Head is a pointer. Yeah, we've seen the head that is just basically pointing to this particular branch. Okay, now let's go into the terminal again and see all of this in action. We look at the Git folder as well. It'll probably make more sense. Just looking at your question. So I'm just looking at the last one because it was a bit more, it required some attention, the topic. I didn't want to lose focus because even I will forget when I'm the particular feature. Does it mean that only I can add new commits? No. No, so that's why collaboration works. So this is a question in the chat for Catalina. How to revert a commit? Yes, we will go through that. I will cover those, how you can revert a commit. There are 3 different ways. And again, it's a bit complex. You need to understand these basic things before you go into more complicated commands. If you don't have this foundation right, it will become very difficult to understand why you have 3 different commands. So for undoing changes, you have a git revert, a git restore, and a git reset. So you need to understand the foundation before you go into those complicated commands. Because if you just go on to Stack Overflow and try to Google, everyone will give you a different answer. If you don't understand what it's doing in the backend, it becomes very difficult. That's what I'm trying to do the, yeah. So actually checkout. So the old way of doing it was doing a git checkout. And when you do a git checkout, it was doing too many things in the background. Okay. That's why now Git is switching to commands, which does one thing. So the modern way or the newer command is using a Git switch, and you can pass a flag to create a new branch as well. Okay. So let's go into our ID, and I will share this now. You will understand it. Yeah. Okay, let's start with a branch first. So I'm in my master. Now let's start looking at things. First, let's run the command called git branch. Okay. So you see, we just have one branch, which is called master. What I also want you to do is look at some of the other things. So the .git folder, which I told you, which manages things very internally. Let's start investigating and looking into that. I'm using more terminal specific commands, but you can obviously open the file and see it yourself as well. Okay. And again, let's not get too caught by the tooling. The concept is, let's focus on the concept and understanding what's happening rather than understanding the tooling here. So I'm using the terminal command. So I'm on master and I want to see what's there in the .git head. Okay. So this is what I was explaining to you. What is your head? You see, it is pointing to ref head master because I'm in my master branch. Head is a pointer to a branch pointer. Okay. It's pointing to ref. Again, this is a folder and I will show you. This is just a directory path. Okay. Within this git folder, if I open this again, within this git folder, you have a file called head, and that head is telling you what this will point to. It says I'm pointing to this particular directory called reference, heads, and master. This is one of the heads, which is master. Okay. And that's just this directory. That is reference, heads, and you have master. Now I want to see what is actually there in master. So let me look at git log. Oh, sorry. Okay. So you see, again, that's what this, your head is pointing to master. It is just a pointer, which is pointing to master. And what is master? Master points to a commit. What is that commit? That commit is your latest commit on your branch, right? So this is the latest commit on your branch, which is your master, and your head is pointing to this master. So let's look at this particular, what's there in this file, okay? So when I look at the Git internal tracking system and I do, okay, .git, what is your head? It tells me I'm pointing at the ref head master. And this is, you see this in your Git log as well. Now, if you go back, and now I want to see, okay, what is my master pointing to? Can you tell me what this would be pointing to in the chat if you're following along? it will point to the latest commit, which is 505EE33, okay? Because master, remember, is only a pointer to the last commit, okay? So let's look at that. So now I will do cat.git, and I have that refs folder, I have the heads folder, and I have the master folder. So you see, when you open this file, it's pointing to the last commit. Okay, and this is in the short form, but if you look at the git log command, that's your commit message, that's your master, and that's where your head is. Okay. Yes, checkout does more than switch command, but we will use switch because that's the newer command, and that's what is now preferred by Git to start using. Okay, so we will use git switch throughout rather than git checkout. There is a place for checkout, and I'll show you when you want to do undo changes and when you want to time travel. That's when you can use git checkout. So checkout will do too many things. That's why we're trying to break it down into more simpler commands. So when we go into traveling in time or looking at our history, that is when we will use checkout. So yeah, so we'll try and we'll try and just switch to using git switch rather than git checkout. Okay. So yeah, that's what I was telling you. So your master is pointing to this particular commit. Yeah, you can look at this again. So that's the commit that it's pointing to. Okay, so we know what our head is pointing to, what our master is pointing to. Great. Now let's start creating a new branch, remembering those concepts. So I'll create a branch called git switch, and let me do a git log as that stage as well, okay? Because it will be important. You have the history. So let's create a branch, git switch. So -c is the flag to create it as well. If this branch was already created, so I can do a feature one here. This branch doesn't exist, okay? So it says it doesn't exist. So I want to create this as well. You just pass this flag, okay? And it says I've switched to a new branch. So you see your master has now changed to feature one, okay? You've seen the change. Now let's try to visit all of those things again. So we first look at our git head, okay? Now you see your head is pointing to feature one, right? So your head will always point to your checked out branch because now if I add anything, it will go into feature one. Your head is the entry point basically. So that's what it is telling you. I am in my feature one branch and your head is also pointing to your feature one branch. Okay. If I do git log at this point of time, you see, now you look at it. This is what exactly I was showing in the diagram. Because I have just created a new branch from master. It's exactly the same commit history. There's nothing that has changed. So now my head is pointing to feature one because my checked out branch is feature one, which is also the same as master. So at this point in time, your master and your feature one are both at the same commit. That's what your head is referring to over here. Okay. And now if I look at the other file, what this ref heads feature one points to, okay. You see, it is pointing to the last commit. So your head points to the branch pointer or the branch reference of your checked out branch, whatever is kind of checked out in your repository or whatever branch you are pointing to, it will point to that particular pointer. And this internally, your feature one points to this particular commit. Yeah, you can. You can still use the checkout branch if you want. I'm just trying to follow the new conventions because I would like the community to know of the new conventions, but you can git branch, git. So the old way was doing was you would create a command called git branch, call feature two. Let's do that. Yeah. So now if I do git branch, you will see all the branches that we have. But we are currently on feature one. So this star means this is on feature one. I'm still on feature one, but I've created a new branch. Now to go into that feature two branch, I will do git checkout feature two. Okay, so now we've switched. So you can do that as well if you want to, but git switch is the new command and I just want to share best practices. So I'm using Git. So you can do that as well, but I am in this particular course, I will continue with Git switch. So now I've created this branch, okay, feature 2, and I want to delete this because I'm just showing you another command because I don't intend to use it. So let's try to delete this now. So git branch -d feature 2. So you will see this will throw an error because I am currently on feature 2. I'm currently on this particular branch. And it says you cannot delete this branch because this is checked out. It's like you have a Word document open and you say, I want to delete this Word document. And it will throw you an error, or this Word document is in use, you cannot delete it. So if we want to delete this branch, we want to come out of this. So I'll do git switch. So now I don't need to use the -c command because my branch is already created. I just want to simply switch. So I will go into feature 1. Okay. So now I can delete my feature 2 branch. So now it was deleted. Okay. That's how you delete a branch. So I am in feature 2 now, and let's go back because now I will be making some changes and I want you to see how the head and the pointer and everything is moving. Okay. So git log 1 line, this is where we are. Okay. It is the same. It is at the same commit as the master. Yeah, I mean, I am conscious of time as well. We'll just complete this and we can cover some of the other concepts in the next because I want you to understand the concept rather than just showing you the commands or run a git branch, but you don't understand what's head. That's why I'm saying the commands are very simple. They are mostly one line. Maybe if we need another session, we can go through that, but I would rather do it properly rather than rushing it. Yeah, so I would rather do it properly because I can just show you the command or git switch and you are in the new branch, but you don't understand what's happening in the backend. So let's take some time to understand these concepts properly. So the related commands will make more sense. So I'll probably just finish branches for today. I know I wanted to cover a few other things, but considering the time, we'll just go with branches for today, and then we'll go through the other concepts. We'll go through the other concepts the next. If we have to add another session, we will do another session. It's not a problem, but let's do this properly. Okay, so let's just complete the branches concept for today. Yeah, so I want to show you now how head and the features are moving. Okay, so where am I? Okay, so I am in my feature 1 branch. I'm showing you what my log commits look like. Now I will add some new. So I want to make some changes. So let's just see what files are there because I've forgotten the files that I created. Okay. So I will create a new file called new feature 1. Okay. Now let's do a git status. Whenever you make any changes, you do a git status. It says, okay, this file, you need to add it to the staging area. So we add this file. I will just use this command and git commit -m. Okay. Yeah, we've added this file. Let's look at our git log now. So now you see your head has moved. It was here first. Your head always points to feature 1. Okay, so your feature 1 moved. That's the first step. Okay, head comes later. So this was the commit that feature 1 was pointing to. Now you made a new commit and your feature 1 pointer moves to the latest commit. Okay, because your feature 1 has moved, your head always points to a branch pointer. Okay, head will always be pointing to a branch pointer, but it changes if your feature 1 is changing. So head points to feature 1 and feature 1 points to this new particular commit. Okay, but now you see this has changed. Previously, your head was same as feature 1 and master because you were at the same commit, but now they are different. So feature 1 and master. Yes, they do point to this particular commit, and that's why they are just a pointer or a name because you can imagine you can't remember these hashes all the time. So we label them or give them a name, like this is the master or this is the feature 1. So in the previous one, both of them were pointing to this particular commit, but now I have made new changes to my feature 1 branch, and that's why my feature 1 now points to this new particular commit. Correct. Yes, that's what it is. So I think Sarah has explained that well. So yeah, because when I created this new branch, they were both pointing at the same commit, right? But now you have made new commits, and that is why they are pointing to different commits. Okay. So that's what has happened over here. Your head and now if we again inspect those files, what is your Git head pointing to? Your head points to feature one. That hasn't changed. But now, what would this file point to? Which is the reference feature one. This will point to the new commit that has just been made, exactly matching our Git log. Okay. So that is what is happening when you're looking at particular branches. Okay, I'm just seeing what else I'm looking at my notes if I wanted to cover anything related to. So we've done Git switch. Yeah, I think we've done everything related to this one. How is everyone doing in terms of time? Like, okay, are we? Okay, I think it's been a long session. We should end this here. So guys, I think we will need a bit more session considering the way we are going. Yeah, I'm not sure. Okay, I want to cover one more thing because we have a lot to cover. And then we can go to the, we'll stop with live. So let's just cover one more concept. It's not going to take so much of time. It's just a bit of command. Okay, yeah, let's just cover one more concept because I do have a lot of things to cover. Even if I do another session, probably I won't be able to do that. So let's cover one more thing, which is stashing. Undoing is a big topic because there are 3 different ways of doing it. We'll cover that later. Okay, so yeah, let's try to cover one more thing, which is called a Git stashing. Okay, and then we can wind this up because I don't have to draw anything. We just work on this repository, and I've already made these changes. Okay. Okay, so we are in our master branch. So we made some changes we had over here. Let's switch back to our master. Okay. Master. Yeah. And I'm just going to try and create a scenario where something has changed on the master. Okay. But yeah. So, okay. I wanted to show you something as well. Let me go back to this because again, this is important. So I am currently in my master branch. Okay, so this is in my master branch. You see, when I was in my feature one branch, I created some new changes. So I created a new file called new feature. I have switched to master. So you see my demo folder, that's my working directory. And that's what I was trying to say. And when you switch branches, Git will make sure you have the changes or that are relevant to that particular branch. So you have not, it doesn't mean you have lost that new file that we created, okay? So you have all of these files here. These were there in both master and the feature one branch, okay? So you don't see the new feature one file. I'm currently in master because that change was not made in master. It was only made in the feature one branch. Let's switch to git switch feature one branch again, okay? So I'm in my feature one branch and let's look at our repository or our working directory. So now I'm in my feature one branch and it's that same working directory which now has that new file that I made changes to. Okay, so Git tracks all of these changes. You don't lose them. Don't be scared that, okay, I've lost one file. I've just switched to master and I don't see those changes are there and it's tracked by Git, but for your respective branch. Okay. So in feature one, I added the file, I see those changes and I go back and switch to master and that change was not added. So you don't see that over here. Okay. So now I'm trying to recreate a scenario where I will make some changes in my master branch. And I'm just making something up. Okay. So I'll just add something called like Women Who Code London. Okay. trying to increase the font. Okay, I'm just adding something, one line over here. And let me add one more thing here, which is called master. Okay, so I've made some changes to this particular file. I am on my master branch. This file is feature1.txt. Okay, and I will add these changes. Feature one. Okay, feature one in master. I know this is odd. You wouldn't do this, but just to make sure we have it clear. Okay, so we look at our Git log. Okay, we've made some changes in our master branch now. And my master branch in feature one has this particular line. Okay, now I switch to my feature one branch. Okay, this commit was not made in the feature one branch. Okay, my feature one had this commit, but it doesn't have this commit. So now if I go into feature one now, I am switched in my feature one branch. If I open this file, as expected, this file doesn't have those changes, which is okay. So yeah, now we are in this branch. So we are in this feature one branch, and we don't have those changes that I just made. So I'm trying to emulate a scenario where, let's say, something changed in master, and I am working in my feature branch. So I am working in my own new feature. It could be anything, and I want to make some changes to it. So I come in and I want to make a change to that same file. So I want to type. I'm making some changes here. I'm just going to increase it. So this same file in the master, I added a different change to it. And in the feature one branch, I'm adding a different change to it. Okay. So let's close this. This is feature one branch, right? So now if I say git status, I see I have modified a particular file. Okay. Now it's the same file that has been changed in master and my feature one branch. Let's try to switch now. What happens? So you see, it is not allowing me to switch. Git is intelligent enough. It tells you, oh, if you switch to master, so all this while I was adding new files, there was no conflict, and I could switch easily between the two branches, right? There was no problem. But now Git is intelligent enough. It tells me, oh, you have made changes to a file. If you switch to master, you will lose these changes because master will override these changes, and you have not told Git. So this is in my working directory currently. Okay. I have not put this in the commit area. This has not been committed yet. I am experimenting with something. My feature is not completed. And for some reason, I have to switch into master. Let's say I'm working on my feature. A colleague of mine tells me, oh, can you look into master? I have a question or I have a concern. So I want to switch to master and look at the changes that are there. Because of the local changes that I have in my repository, I cannot switch. So because Git is telling me your local changes to this files will be overwritten by checkout. So you have two options. Either you commit them, so I can commit these changes, or you stash them. If I feel my changes are ready, I can commit them like I've been doing all of this. But at this point of time, I feel my changes are not ready. I don't want to commit these changes. And I have these bunch of files. Okay. The other option is to stash them. Think of stash as a backlog. Okay, so it's like a backlog where I'm working on, not a backlog actually. It's like a backstage kind of area. So you have a staging area. Think of it as a backstage area. So you're working on your working directory and you are not complete with your changes, but you have to now switch your branch. You can move all these changes into a backstage area, which is called a stash, where all your changes will be preserved. Okay, it will preserve all of these changes. And when you are ready, you can tell Git, okay, Git, I am ready now. I want all of those changes back. So you can apply those changes back into your branch. Okay, so let's look at this command. So if I do git stash, git stash list is the command. Yeah. So if you look at git stash list, you see there's nothing in it. Okay. There's nothing in it. You see the status. My status says I have one modified file. So if I want to put this into the backstage area, I will just run the simple command git stash. Also, let me show you the Git log so I can compare all of that. Okay. And now I will just run the command called git stash. So I have one file that has been modified. I don't want to commit it. I want to put it to the backstage area. This is where my feature one branch is currently pointing to, and my git stash is empty. Now I run the git stash command. Okay, so it says save your working directory and index state. It just puts it, gives it a meaningful name. It's called work in progress on feature one. And from where is it saving? It's saving from this particular commit. So this is the last commit, and anything above this has been saved into the stash area. So now if I run the git stash list command, you see it has this particular stash. It just gives it a number. I think it just uses this certain kind of an index to say, okay, whatever changes you made in this particular branch after this commit on this particular branch, feature one, after this commit are in your stash area now. Okay. Now let me look at my git status. So again, it shows working tree clean, nothing to add. Let me look at my feature one file. So I did add some changes to it. Those changes are gone. So basically Git has put all of those stages in a changes in a backstage area. Now, will it allow me to switch to master? So my working tree is clean. There's no conflict. Now I can switch to my master. Okay. So that's how you preserve your draft changes which you're not ready to commit confidently. Because otherwise, what you would have done, and this is a lot of beginners do, they will commit some files which are not ready, and they will make another commit and then do another commit to recorrect those files. But when you work on big open source projects, every commit history counts. You have thousands of collaborators, hundreds, maybe not even thousands, who are working on these projects. And if your Git history is not clean, it is very difficult for them to collaborate or understand your changes. Okay. So in your own working folder, you can add anything because it's only you who are working on it. But when you're working with a team of developers or people, we need to be very careful of every commit history that we have. Okay. So it's not a good practice to commit changes if you're not ready. You put them in your stash area, you complete the work. So I'm in my master. I had to look into a certain issue. I've looked into it and now I want to go back to my feature branch. Okay. So I will go back and switch into my feature one branch. Yeah, and now I'm ready to apply those changes. So there are two commands that you can use. One is called git stash pop, and the other is called git stash apply. So what pop does is pop will remove that. So I will first do actually a git stash apply. So let's look at git stash list. Okay, so you have this one particular changes in your stash area. Let's apply git stash apply. So basically what apply does it will apply the changes, but not remove it from the stash area. Okay. So I will do git stash apply. So you see that feature one file, which I had modified, it is back in my working directory, however it was, right? So if I go back now in my feature one, and you see, I have got back those changes which were there in this particular file, right? So it's exactly in the same state where it was before I did the git stash. Now the git stash apply command, like I said, only applies those changes and doesn't remove it. So if I do a git stash list, those changes are still there in my stash. If you want to remove them completely, the command is git stash pop. Okay, and it will remove that from the stash completely. Okay, because I've already applied it, I won't apply it again. And if you want to clear these changes, so let's say I didn't apply, and now I don't need this anymore. I thought maybe I will need those changes. So instead of doing a pop, I put it as I didn't apply, but now I don't need it and I want to clear my stash. You can do git stash clear. And let's do a git stash list and it's gone. Okay. Yeah. So yeah, that was stashing. Yes, it will apply and remove the change. That's right. So git stash pop will apply and remove the change. I wanted to show you both the versions. You can do both apply and both pop. Yeah. So yeah, that was git stashing. That's how you manage your unfinished draft changes if you have to switch between branches and there are conflicts. If there are no conflicts, like we've been doing all of this while, you can switch. But in case if you see a message like this one, again, it's nothing to be like scared of, or I don't know how to manage this. And that's why it's important to understand some of these basics before we go into these complex commands. Okay. Just trying to find that message. I can't find it. But yeah, it wasn't allowing me. Yeah, that's what I'm saying. You cannot switch because it will be overwritten. So that's how you manage by using stash. Cool. Yeah, yeah, we've seen all of those commit messages. Okay, I think we will wrap up here. Thank you very much. If anybody wants to come on mute, I think we've answered all the questions in the chat, but yeah, thank you. Thank you for the feedback. Okay, yeah, I will share some exercises by the end of the day, and you will have access to the recording as well. If you want to take a look at these exercises and go through these workflows. So the exercises will cover all the commands that I have walked you through today. And you can like practice all of those commands, but I will give you exercises so that you can go through the same workflow. And I'm very thankful to all the volunteers that have reached out to me. I will reach out to you over the weekend because the help that we really need is with the exercises. So I want to capture solutions for those exercises as well. And it would be really because we're doing this session now. And if somebody later wants to come and look at the answers of those exercises, it would be very helpful to capture the solution for those particular exercises as well. And that's why I needed some volunteers to help me add those solutions. We've had a lot of response for people who are willing to contribute. So thank you very much for your time. But yes, I will reach out to you over the weekend. And if you have, as you're practicing those exercises, you can capture the solution and contribute to the Women Who Code London repository so that it kind of builds a kind of an education material for people where, okay, they can watch this video, practice those exercises, and for their reference, they will also have answers with them. So yeah, that's what we want to do with the volunteering, with the volunteers. And yeah, I will reach out. I will send those exercises by the end of the day, and I will reach out to the volunteers as well. Thank you very much. Okay. Thank you everyone for joining.